So, hi guys, I'm Christina Yvonne Cruz, and for the assignment number 2, I was assigned to number 24. So, this is the problem. So, we have this circuit, the figure 3.73, and it is a single node pair circuit. So, we are asked to determine the power absorbed by each resistor, and then for letter B, we are asked to determine the power supplied by each current source, and then for letter C, we have to show that the sum of the absorbed power calculated in A is equal to the sum of the supplied power calculated in C. So we have a closer look of the circuit. So this is our circuit. And then here is a simpler version of this circuit. So yeah, we have this. Here's the 1 kilo ohms, which is originally here. And then we have the 2.8, and then between it is the 3 milliamps, and then the 4.7 resistor, and then the 5 milliamps. So for the solution, for letter A first, which is we are asked to determine the power absorbed by each resistor. So we are asked to assume a voltage across the element. So this is that voltage. So we have this V over 2.8, which is the 2.8 resistor, plus 3, which is this, and then 1.10 plus 4.7, and then it is equal to the 5 current here. And then we were able to get the voltage, which is 1.27 volts. Now, to find the power absorbed by each resistor, we have to use the formula for power, which is equals to V squared over R. So we have to get now the power of each resistor. So we first start with the 1 kilo ohm resistor, which is this one. Now we are going to use V squared. The V that we got from the previous part, we were going to plug it in here. So 1.27 squared over 1.10, which is the 1 kilo ohm resistor. So it is equals to 1.6129 times 10 raised to negative 3 watts. And then we do the same thing for the next two resistors, which is the 2.8 and the 4.7. So here it is. V squared, again, the 1.27 volts, and then we were able to get the power absorbed by 2.8 kilo ohms resistor, which is 0.576 times 10 raised to negative 3 watts. And then for the 4.7 kilo ohm resistor, we were able to get a power of 0.343 times 10 raised to negative 3 watts. Now let's proceed to letter B, which is we are asked to determine the power supplied by the current source. So for this part, we again assume a voltage across the elements, which is the same thing that we did in part A. So we have still the V, which is equal to 1.27 volts. So in getting the power in current, we have to use the formula V is equals to VI. Now for our current, which is equals to 3 milliamps, it is negative because from the circuit it is downward. So V is equals to negative VI. We have V as 1.27. So we multiply the two and we get the power supplied by 3 ME source is negative 3.81 times 10 raised to negative 3 watts. And we do the same thing for 5, and it is positive because there, upward. So we get the power supplied by the 5 MA. I'm sorry, this is just a typo error, which is equal to 6.35 times 10 raised to negative 3. Now for the last part, we have to prove that the power absorbed by each resistor is equal to the power supplied by the current. So we have to get the sum of all the power from each resistor, and then prove that it is equal to the sum of the power supplied by the current source. So you have this as the solution. So here's the solution. We we add all the power from 1 kiloohms, 2.8, 4.7. So we got the total power absorbed, which is equal to 2.532 milliwatts. And then we do the same thing for the current sources, which is the power supplied rather from the 3 milliamps, negative 3.81 times 10 raised to negative 3, plus the power from the power supplied from the 5 milliamps, which is 6.35 times 10 raised to negative 3. So we got 2.54 milliwatts. So yeah, they're approximately equal. We can conclude that the power absorbed is approximately equal to the power